In this video, we're going to discuss generative models. So let's get started. Generative models, a type of machine learning model, have the capability to generate new data that is similar to the data they were trained on. This makes them useful for multiple things, like creating new artwork, music, or even scientific simulations. Think of these models as chefs in a gourmet kitchen. Just as a chef uses ingredients and cooking techniques to create new dishes, generative models use data to produce new, realistic outputs based on what they've learned. Generative adversarial networks, or GANs, use two neural networks, a generator and a discriminator, that compete with each other. The generator makes new data, while the discriminator checks if the data looks real. This process helps the generator improve, making its outputs look more and more like real data. You can think of this as a forger trying to create a convincing fake painting, with the discriminator being the art critic who decides if the painting is real or fake. Another type of generative model is the variational autoencoder, or VAE. VAEs work by compressing data into a smaller form and then reconstructing it. This is like a sculptor who shapes clay into a compact form, stores it, and later reshapes it into the original form. VAEs are great for tasks that require a deep understanding of data structure, like reducing data size or controlling specific features in the generated data. A newer type of generative model is the diffusion model. These models start with random noise and gradually turn it into meaningful patterns that look like the training data. This is like watching a photo develop in a dark room where an unclear image slowly becomes clear. Diffusion models are known for creating detailed and high-quality images, though they need a lot of computing power. Training these models is not easy and comes with challenges. GANs need a careful balance between the generator and discriminator to avoid problems like mode collapse, where the generator only produces limited types of outputs. Diffusion models require careful tuning of the noise reduction process, which can be demanding. Despite their capabilities, generative models have limitations. One big issue is data bias models can replicate any biases in the data they are trained on, leading to biased outputs. There are also ethical concerns, especially with creating realistic but fake images or text known as deepfakes, which can be misused. Additionally, these models require a lot of computational resources, which can make them inaccessible to individuals or smaller organizations. As we move forward, it's crucial to not only enhance the technical capabilities of generative models, but also address their ethical implications and ensure responsible use. By maintaining a balanced approach, we can maximize the benefits of these powerful tools while minimizing risks, ultimately benefiting society.